Assalamu alaikum. Dear students, today our topic is about the circle. This topic is in your textbook, and after completing this circle, we will we will study another topic, newly added topic, areas related to the circles. So, you have read already about the circles in your previous class. Let us recall the definition of a circle. What is circle? Circle is a collection of pointers or set of pointers, you can say, whose distance from a fixed point whose distance from a fixed point is constant. So what is circle? You collect infinite collection of the pointers in such a way that the distance of each and every point is constant from a fixed point. For example, this is your collection of pointers. If we collect pointers in such a way, suppose this is fixed point here. So if we find the distance of this point to this fixed point, this point to this fixed point, this point to this fixed point. In fact, there are infinite number of pointers, and you will see if you find the distance of these infinite pointers from this fixed point, all these distance would be constant. Constant means equal. All distance would be equal. So this is the definition of circle. And you can collect, you can have collected the point set of points in different way. For example, we can have collected it in this way also. This is also a collection of the pointers, but this is not a circle. Why? Suppose this is fixed point here. If you find the distance of this point, its distance would be as such. You may see this is long, you may see this is short, you see this is short, and similarly for the other pointers. So this is not a circle. The distance should be equal from the center to the all pointers. This fixed point is known as center. And this constant distance is known as what? Radius. So in short form, if we have a circle C, center O, radius R, we denote it by circle C, center O, radius R. This is short notation of the circle C, center O, radius R. You have read it in your previous class, so it was just a recapitulation. Now another point which is very important, that is the tangent. What is tangent? What is tangent to a circle? A tangent to circle is a line which intersects the circle at one point. You know it. This is a very basic definition. Tangent is what? Tangent is a line which intersects the circle at one point. This is your tangent. A tangent is a line which intersect the circle at one point. What is secant? A secant is a line which intersect the circle at 2 points. This is secant. This is your secant. This is your tangent. And what is chord? Chord is a line segment which joins the 2 pointers. Chord is a line segment. Secant is a line. Chord is a line segment which joins the 2 pointers on the boundary of a circle. These are the very basics you are already familiar with. Now the important topic which we are discussing, which we have to discuss here, is the theorem, which is in your textbook. That the tangent, I will write the theorem first here. Theorem is a tangent. It is in your textbook. To a circle is perpendicular to the radius through the point of contact, to the radius through the point of contact. This is the theorem. You have to prove it. First of all, what is point of contact? Look here, this is your tangent. If this is your tangent at point P, point of contact is that point at which the tangent lies, tangent falls. At here P, here this AB is tangent. AB is tangent to a circle at point P. This point P is known as the point of contact. Point of contact. So point of contact is that point at which the tangent falls to the circle. So I hope you will get it. So what we have to prove is that tangent to a circle at the point of contact is perpendicular on radius. I will explain it to you. You have a circle. This is your tangent. This is your tangent. This is your point of contact P. So this point of tangent, this is tangent. This is your radius. This theorem says that this tangent is perpendicular to radius. At what point? At point of contact P. Means the point at which the tangent and the point at which the radius and the tangent meet here, this point, they make the angle of 90 degree. You have to prove it. How will you prove? How can we prove this? Take a look. So to prove any to prove any theorem, you must have you should know the three things given. You should know to prove what is given to us, what we are supposed to prove, and then later using the given you have to prove you have to give the proof to the theorem. So we will write it. We will draw a figure again. This is your tangent. This is your tangent at point of contact P. This is your radius OP. So what is given? We will write given. What is given? AB is tangent to the circle at a point of contact P. Is it? Yes, it is. AB is tangent to the circle. AB is tangent to this circle at the point of contact P. So next step is to prove. To prove what we are supposed to prove. To prove OP perpendicular on AB. OP perpendicular on AB. So also in sometimes we need some necessary, we take some necessary constructions to prove our theorem. We will take it, we will do some construction. Take point Q on AB other than P. We will take point Q here. Take point Q on AB. P also lies on AB. We have to take another point Q. Take point Q on AB other than P. Other than P. So I hope you will understood this up to this level, up to this step. Now proof. We will write the proof. Proof is very simple. We will join this O to Q. We will join this O to Q. Join OQ. Join OQ. We have joined it. Join OQ. This Q, this point Q must lie outside the circle. This Q this q must lie outside the circle. Why? This q must lie outside the circle. For if it lies inside, I will explain it to you. For if this q lies inside circle, then this AB becomes secant. Take a look. If we bring this q inside the circle, here I will show you. Suppose this is your AB, this is your B, this is your A, this was your O. Sorry, I will do it again because this is your P, this is your O, this is your A, this is your B, this is your Q. Take a look. If this Q lies inside the circle, if we bring this inside the circle, then AB becomes what? AB becomes a secant. But what is AB? Given AB is tangent, which contradicts, which opposition our statement. We are given that AB is tangent, but if we bring Q out inside the circle, so this is contradicting our the statement, given statement that AB is tangent. So this Q must lie outside this circle. You have to write for if it lies inside, then AB becomes secant. AB becomes secant. But AB is what? AB is where AB is tangent, which is contradiction. So suppose now, which is contradiction. Suppose we will take another point on, so this Q must lie outside the circle. As you know, we have proved it, we have given the explanation. Now we will prove it further. Before that, pause the video to note it down. I'm sorry, I have here the unavailability of the space, so I have to rub it. Now, as we have proved that this Q must lie outside the circle. Clearly, have a look. This OQ and this OP. This OQ is greater than OP. As Q lies outside, this lies on the boundary. OQ is greater than OP. Is it? Of course this is. Or we can write OP is less than OQ. Can we write it? Of course we can. Suppose if we take another point for your, this is true for actually this, if you take any point on this AB, you will find that this OP is less than the distance of that point to the point on AB. Suppose we will take here M. You have to write it for your simple. You did not mention it here, but I am showing it to for your explanation so that it may clear to you. If we join this, is OP less than OM? Of course, OP less than OM. Suppose we take another point, say N. Again join this. Is OP less than ON? OP less than ON, of course. Suppose S. Join it. Is OP less than OS? Of course, OP less than OS. Suppose T. Is OP less than OT? Of course, OP less than OT. How many points we can take on AB? Infinite many number of pointers. And if you join these pointers to O, you will find that OP will always less than the OP will be always be the less than the line segment joining those pointers to the O. So I hope you will get it. So OP will be the short. OP is will be the smaller than the line segment. Line segment OP is smaller than the line segment with joining the pointers on OB, with joining the points on AB to point O. I have explained it to you. You take any number of the pointers, you will find that OP is the less. Sinus. So you have to write it. You may write it for your explanation. You may keep it aside, but in the proof, in the examination, you have to write just sinus. I will here sinus. This is true for all pointers. Since this is true for true for all the points joining. This is true for all the pointers lying on AB, which are joined to O. So you may take any number of the pointers on this, you will find that OP is less. That is, OP is the smallest distance. OP is the shortest distance. That is, OP is the shortest distance. So we get of all the distances, of all the line segments or distances, we may write OP is the shortest one. OP is shortest one. And you know, shortest one is always a perpendicular distance. Take a look. Suppose you have here two lines. If you have to find the distance of this line to this line, you will join this point to this point to this point to this point to this, and this point to this. The distance which is shortest, you will find it is always a perpendicular distance. Remember this thing. Shortest distance is always a perpendicular distance. Remember, whenever we have to find the distance between the any two quantities, we always find it, take it as a perpendicular distance. Perpendicular distance is the shortest distance. So since OP is the shortest distance, and shortest distance is always what distance? Perpendicular distance, and the shorter one is perpendicular from, therefore OP is perpendicular on AB. You may write here the reason as perpendicular distance. Perpendicular distance is always shorter distance. So this proves the theorem. This proves your theorem, which we were supposed to prove. So what was the theorem? That if you draw a tangent to a circle, it is perpendicular on the radius at the point of contact P. So its converse is also true, but that converse is not in your textbook. But still, I will show you. We will look into this, that what would be its converse theorem. So I hope you will understand it. Before that, pause the video to note it down. So converse theorem is that if you have a circle, converse of this theorem. If you have a circle, suppose if you have a circle, this is a line, this is your line, say L, but it seems it is tangent, but we need a proof. Suppose this is line, we don't know it is tangent, and this line is what? This is your point of contact P. If you throw the P, you have drawn a line L perpendicular to this radius of P. Perpendicular to, through P, you draw a line L perpendicular to OP. So this theorem says that this L must be tangent. L must be tangent. What was in the first case? You were given the tangent. You were supposed to prove that this is perpendicular. So in reverse case, what you are given with that this is the perpendicular. This is the perpendicular here. You have to prove that L is tangent. So we will write just a statement that a line, remember this, a line drawn through, a line drawn through the end of radius, and perpendicular to it, and perpendicular to it is a tangent. is it tangent to a circle? Is it tangent to a circle? This is converse theorem. In first case, you were given the tangent, you were supposed to prove that this is perpendicular to radius. Now in the second case, you are given the line, a line which is perpendicular to the radius. You are supposed to prove that this line L must be tangent to the circle. So I hope you will understand this, and still after watching this video, if you find any confusion, any doubt, please mention it in the comment box. I will make the video, or I will explain it to you, and in the subsequent videos we will do some textual questions. And also I request you to subscribe my channel Let's Learn Mathematics, and rate, review. If you have any suggestion, it will be most welcomed. Thank you class.